This video tutorial from Exocad will show you how you can quickly design a 3-element bridge. To start, run the DentalDB application. Note that there is a separate tutorial showing you how to set up new cases in the DentalDB. For this tutorial, we load an already existing sample case instead. Click the Load button at the top of the DentalDB. Select the demo sample called 3-Element Bridge Virtual Articulator Copy and Paste Sample and click the Load button again. This sample's job definition includes 3 different restoration types. For tooth 46, we defined an anatomical crown. For tooth 45, we defined a reduced pontic. For tooth 44, we defined a coping, which is a reduced crown. By default, connectors will be set automatically whenever you define a pontic, and thus the toggle buttons are colored in green. Click to toggle. The color will change to gray and no connector will be created. In practice, you will use this feature mostly to add connectors between adjacent crowns or copings. Click again to create a connector. Note that if the color button is red, a connector may not be created because the material of the adjacent teeth differs. And if no toggle button is present, one of the selected types does not permit connectors. Before we proceed to the design, I will slightly change this job's material configuration. I want to design this job with a 3/4-axis material. To do that, it is enough to select one of the teeth. Select 3/4-axis in the Material drop-down list and reselect the desired material for the 3/4-axis material configuration. Note that the last selected material configuration will be used for the next project. Click OK to apply the changes, and choose Change Material for Bridge to apply this 3/4-axis material configuration to the whole bridge. Otherwise, you must change the configuration for each tooth. Before you can proceed to the design, you must click the Save button to enable all Actions buttons, as you did crucial changes in the project configuration. Now click the Design button to proceed to the design. In the DentalDB, we defined the scan mode for 2 stone models in Articulator A. Thus, the wizard will start automatically with the virtual articulator if this add-on module is activated on your dongle. To have a better visualization of the virtual articulator's effects, I prefer changing the antagonist transparency in the Show Hide window now. You will find more information about the Show Hide window in a separate tutorial. Let's start with the articulator. Note that if you don't want to use the articulator, simply click Next in the wizard to skip this step. Right now, I don't want to go too much into detail about the virtual articulator feature with its different articulator types and parameters. This will be explained in a separate tutorial. I directly start the articulator movement simulation with the default parameters. Note that this operation must be executed before clicking OK in order to save the articulator movements for a dynamic occlusion adaptation later. When you close the virtual articulator dialog by clicking OK, a new window will appear at the top right corner of the screen. This window allows you to visualize and repeat the 4 main articulator movements. The articulator is not visible here. Showing the articulator is not necessary, as the virtual movements have been saved. Let's proceed with the next step, which is the margin line detection. Here, it is very important to click the margin line for the tooth number shown in the wizard. In most cases, 1 click is enough for the margin line to be detected. Ensure that the margin line has been detected correctly for the entire tooth. Then click Next to proceed to the next tooth. And define the margin line for this tooth. If the margin line has not been detected correctly, you can improve the detection by adding one or more points on the margin line. If you have erroneously added a point which is not actually on the margin, switch to Remove Point and click the points to remove. Alternatively, click the Correct Draw tab to manually adjust the margin line. You can move points by clicking and holding the left mouse button. Add points by left-clicking the green line. Remove points by left and then right-clicking the point. In a separate tutorial, we will show you more margin line features. Click Next to proceed to the next step. As we have changed the material configuration to 3/4-axis mode, we are always prompted by the wizard to verify the insertion direction. Furthermore, the 3-axis mode enforces a unique insertion axis for bridges. Note that in 5-axis mode, you are not always prompted to define or adjust the insertion direction. This only happens if the direction is not ideal. At any point, you can still easily change the insertion direction in the right-click context menu. In a separate tutorial, you will find more information about the insertion direction step. Rotate the view so that you look into the preparation from the desired insertion direction. While rotating, undercuts are marked in red. Then, click Set Current View as Insertion Axis to define the view as the new insertion direction. Click Next to proceed. The Crown Bottom step allows you to design the inside of the crown. This part of the design and the parameters involved are crucial for a proper fitting. This step, including border and undercut settings, will be explained in more detail in a separate tutorial. Click the Next button to proceed to the next step. The Copy Tooth step allows you to use copies of existing teeth as library teeth or pre-op models. This will be explained in a separate tutorial. Let's proceed to the next step, which is the tooth placement. In this step, you can optimize the tooth model placement by moving, rotating, and scaling the teeth. The default operation is Move. Move the tooth freely in all directions by holding and dragging the left mouse button. Click Rotate to rotate the tooth in all directions by holding and dragging the left mouse button. Click Scale to scale the tooth in all dimensions. To do this, hold and drag the left mouse button. All transformations, moving, rotating, and scaling, can be restricted to certain directions. If you want to move the whole tooth bow, click Move All simultaneously. With Control and right mouse click, you can deselect teeth. In a separate tutorial, you can learn more about tooth placement and how to use the direction restrictions. Instead of using the mouse for switching between the transformation modes, I recommend to use shortcuts to quickly toggle modes. To activate those shortcuts, check Move, Scale, Rotate in all directions. Hold only the left mouse button to move the tooth. Hold Control and the left mouse button to rotate the tooth in all directions. Hold Shift and the left mouse button to scale the tooth. And Control and Shift to perform direction-based scaling. Using shortcuts will save you a lot of time. Certainly, you can undo or redo all actions. With Exocad DentalCAD version 2016, the Chain Mode feature is available in the Tooth Placement dialog. The Chain Mode is a great tool for full arch tooth placement. A few clicks are enough to do such a setup. This will be demonstrated in a full separate tutorial. Let's now do a nice tooth placement for this case. When placing tooth models, it can be helpful to visualize intersections with the antagonist, especially if the antagonist is hidden. A new window appears, and the software displays the intersections with the antagonist for each restoration, color-coded as illustrated in the color scale. Show distances provides some more options if expanded. These options will be explained in a separate tutorial. Usually I set the view from the top to start placing the teeth in a line. Then I move to the frontal view to modify the tooth axes. Then I move the jaw to the side view for adjusting the tooth height position and the curve of spee. Normally I hide the antagonist during the initial placement. I think the colored contact intrusions are enough, as I'm not too critical with the occlusion now. Following the patient's tooth bow is more important, as the final occlusal adjustments can be done very easily in the free-forming step. Click Next to continue. The tooth models will now be adapted to the margin line. Let's have a look at the free-forming step. Now I normally activate the antagonist in the Show Hide window. A semi-transparent display of the antagonist might help you to adjust the contact points more accurately. By default, the free-forming tool starts with the anatomical free-forming, which allows you to adjust the tooth shape by areas. Choose Cusps to edit individual cusps. This is a perfect tool to create or adjust the contact points. Choose Tooth Parts to edit the mesial, distal, buccal, and lingual side wherever you click on. This function can be used to perform bigger adjustments very quickly. Usually I use this tool to adjust occlusal contact points. But also to establish or adjust the proximal contact point areas. The same on the distal side of tooth 46. Furthermore, I recommend to use this tool for placing the basal part of the pontic correctly. You can keep certain parts of the tooth fixed, either the cusp tips or the equator. Check Cusp Tips to keep the cusps fixed while moving the equator. Uncheck Cusp Tips and check Equator to keep the equator area fixed when editing the cusps. Choose Entire Tooth to remove the entire tooth. As in almost all steps, you can undo or redo operations here. Choose Ridge for fine-tuning of ridges and bulges. Now, click the Free tab to switch to the virtual wax knife. This is a useful tool to do fine tweaking on your design. Choose Add Remove Material to add or remove material. You can use Shift and the mouse wheel to adjust the brush size, and Control and the mouse wheel to adjust the strength. To add material, click the crown and hold the left mouse button. Hold the left mouse button and Shift to remove material. Hold the left mouse button with Shift and Control for simple smoothing, or toggle to smoothing. You can change the strength of the smoothing, or perform a very aggressive super smoothing by holding the left mouse button and Shift. To perform shape-preserving smoothing, hold the left mouse button and Control. For both modes, 3 brush types are available. In a separate tutorial, you will learn more about the free-forming step, with more detailed information and examples on how to use the shortcuts. Let us now switch to the Adapt tab, another very important tab in the free-forming dialog. Here you can adapt the pontic to the gingiva, the occlusion, and the proximal contact points. Note that if you proceed to the next step in the wizard without having performed the adaptation, a hint will remind you to perform this step. By default, the Adapt step starts with the adaptation of the pontics to the gingiva. In all adaptations, you can define a desired distance by using the slider by typing in a value. 0 means full contact. A negative value allows intersections, and a positive value creates a gap. You can check Pull down to gingiva if the pontic is not in contact with the gingiva. In our case, we don't need that option. Click Adapt to gingiva to perform the adaptation. Let's toggle to the occlusal adaptation. Also here, you can define a desired distance to the antagonist using the slider or by typing in a value. A positive value creates a gap between the restoration and the antagonist. This is comparable to moving the antagonist downwards in the articulator. A negative value allows intersections, which is similar to moving the antagonist upwards. I recommend to use the distance option instead of the correct antagonist feature in expert mode if you want to adjust the occlusion height. Since we used the virtual articulator in the beginning, we now have two different occlusion adaptation types, static and dynamic. Let's try the static adaptation. The static adaptation type only cuts the intersections with the antagonist on its fixed position. The Show Distances window allows you to verify and to display intersections which occur during movements. And yes, there is still an intersection with the antagonist when performing the retrusion. This is because we performed a static adaptation. Other movements can also create intersections with the antagonist here. By chance, our design doesn't have other intersections. Here you can really see the intersection between design and antagonist when the retrusion is at its maximum position. Let us undo the static adaptation and compare it to the dynamic adaptation. Check Dynamic Occlusion Type and repeat Cut Intersections. Display again all intersections that might have been created by articulator movements. Now, logically, there is no intersection anymore. Even the retrusion movement does not present any intersections. Let's perform all other virtual movements too. Laterotrusion left, laterotrusion right, retrusion again, and protrusion. As you can see, there is absolutely no intersection anymore. The jaw movements are mostly guided by the healthy teeth. Again, I will undo this operation to show you another adaptation type. Besides cut intersections, you can do a smart shape-preserving adaptation, which will try to preserve the tooth morphology. Note that this feature can change your design slightly. I will undo this operation too, as I prefer to simply cut the intersection with a dynamic occlusion. Furthermore, you can exclude parts from the adaptation. Imagine there is not enough space for the ceramic, and you want to ask the dentist to remove some material on the antagonist during bridge placement. The parts brushed in blue will thus not be adapted. We finish that step with a dynamic intersection cut. We can now proceed to the approximal adaptation. Here you can see the intrusions on the distal side of adjacent 43 and on the mesial side of adjacent 47. Set the desired distance the same way as you did for the pontic and occlusion, and decide which kind of adaptation you want to perform, either a simple intersection cut or a shape-preserving adaptation. The approximal adaptation provides another option called Pull Sideways to Adjacent Teeth. You can use this option to close gaps between your design and the adjacent teeth. In the approximal adaptation, you can also exclude parts from being adapted. Click Next to proceed to the next step. In the shrinking step, you can reduce the anatomic shapes in order to create reduced frameworks, where you can apply veneering material such as ceramic. The shrinking step and all parameter settings will be explained in a separate tutorial. The Cutback Design Library feature and multi-level cutback will be explained in another separate tutorial. In this tutorial, we just define and verify the shrinking depth and the minimum thickness before we apply the shrinking. Maybe you will notice that tooth 46 will not be shrunk. This is because we defined an anatomical crown for this tooth in the Dental DB. Click Next to proceed to the next step. After the cutback, you can do some free-forming again, but now on the reduced teeth. Normally I use the Tooth Parts option to do final corrections on the reduced shape, especially to ensure that there's enough space for the veneering. If desired, you can use Smooth Flatten to create a smoother shape. Note that the minimum thickness displayed in red cannot be violated. It will be recomputed when proceeding to the next step. The basal part of the pontic can be designed easily with super smoothing. Hold Shift and the left mouse button to delete material and to smooth the pontic in this area in one step. Then go back to the Adapt tab, Pontic activated, and enter the desired distance to the gingiva to ensure you have a uniform gap for the veneering here. Feel free to toggle back and forth between the two modes until you have achieved the desired design. You can also toggle between free-forming and Adapt Occlusal to smooth the contact points for creating a more natural appearance. After shrinking, the Occlusal adaptation provides an additional distance for the reduced parts. Verify and finalize the design of the reduced tooth elements. You should also display the antagonist to verify if there is enough space for the veneering on the occlusal side of your restoration. The fourth tab, Attachments, in the free-forming dialog will be explained in a separate tutorial. Proceed to the next step. The Connectors step allows you to design the connectors between the tooth elements. Connectors will be generated wherever defined previously in the Dental DB, but can also be added or deleted afterwards. To delete a connector, right-click the connector and select Delete Connector. To add a connector, right-click one of the elements you want to connect and select Connect to Mesial Distal Neighbor. The minimum size of the connector can be defined either by its cross-sectional area or by its height and width. Toggle between the two modes using the radio buttons, then adjust the value using the sliders. To apply your changes, click Apply cross-section shape change. Each change must be applied. You can also switch between different predefined shape profiles by clicking shapes. Any changes you make will be applied to all connectors. In expert mode, you can apply different parameters and shapes to individual connectors. This will be shown in a separate tutorial. Starting with Exocad version 2016, there is the connector type Join Tooth Shapes directly. You can use this shape to connect full anatomical crowns. This will be demonstrated in a separate tutorial. Once you have defined the connector shape, you can position it in different ways. To change the connector's position, drag and drop it using your mouse. It will readapt itself to the teeth once you drop it at its new position. Dragging the connector will change its position on both sides. To change the docking place of the connector only for one side, hold Ctrl and the left mouse button to drag the point, or hold Ctrl and click the tooth to change the docking point's position. Hold Shift and the left mouse button to drag the middle line area of the connector. When generating connectors, the software tries to enforce the minimum cross-sectional area, or the minimum height and width. In some rare cases, this may fail due to space restrictions. The connector will then be displayed in red. This situation requires manual work to be resolved. Try changing the connector's position by dragging and dropping it, or by repositioning the docking points, or freeform the connector. Switch to the Free tab to customize your connectors further, or to visualize the connector thickness. You can now edit connectors by moving control points. When you move the mouse close to the control point, it will increase in size and arrows appear. Drag and drop the arrows for movements restricted to the arrow direction. Drag and drop the control point itself for free movement in all directions. To insert additional control points, hold Ctrl and click the green line in the connector's center at the location where you want to add a new control point. Hold Shift and the left mouse button to move the center line. Click OK to proceed to the next step. The restoration will be merged and saved now. In this last wizard step, you can decide what to do next. I'm done means that the scene will be closed and saved. Proceed to production launches the integrated CAM module, Exocad. Freeform restorations allows you to freeform the entire merged restoration. Expert mode allows you to further edit your restoration. For example, if you want to change the margin line or the insertion axis, or certain other things, you can still do this now without losing your existing design. For details about the expert mode, please see our separate video tutorial. Design Model will start the Model Creator module. Now I will show you the advantages of the Freeform Restorations option. The software will now stitch together the elements of the restoration. In this freeforming step, you can now use the known freeforming tools on the entire restoration. And here, smoothing and melting in the areas between elements is possible too. You can also make connectors thinner. Click Visualize Connector Cross-Section to verify the connector thickness. Magenta color indicates that the connector is thinner than the specified minimum cross-section. In such a case, add material to make the connector thicker. Click the button again to check its thickness. Using anatomical freeforming, you can pull and drag entire restoration areas. Note that if you do freeforming on merged parts, these changes will be lost if you delete constructed parts in expert mode. When you're done, click Next to proceed and finish the restoration. The software asks if you want to save the modifications. The restoration will be exported again with the changes you've made. The previously saved STL output file will be overwritten. Thank you for watching this video.